Are you spending too much time on one quant question? This is where iQuanta's CAT module comes in. Here you will learn time-saving techniques, smart shortcuts, and pattern-based tricks to crack quant questions within a few seconds. Because in CAT, every second counts. Boost your speed, maximize your score, cut the time, not the accuracy. In this video, we will dive into linear equations, the first chapter of Algebra. And this will not be traditional long approach. It will be cut short. That will save your precious time in the real CAT paper. Let us cut the clutter and solve linear equations in a snap. Hey there, linear equations form the basics of algebra. That's the first chapter even in the class, and today I'll be discussing an alternate approach about linear equations. And certain things are there which are kind of we do in class as well, but then just the shortcuts, generalizations is what I'm going to share today. Straight line, the general form is ax plus by plus c equal to 0. Now what's the utility of this form? To write something in this form, what's the utility? There can be multiple utilities, but first thing first is identification of a straight line. Whether it's a straight line or not, how do we know? When the power of x and y both are equal to 1. In fact, we can also have an equation in one variable. When I say that, so this is the x and y axis, the Cartesian coordinate system. If I say I want to write, because this y axis is also a straight line. If someone asks me to tell me what is the equation of y axis, equation of y axis? Is that even possible? Exactly, it's possible. If I write x equal to 0, what does that mean? I need all the points where x equal to 0. Now x is 0 over here. So 0 over here, everywhere x is 0. Y can be anything. So x is 0 represents the y-axis. When I say y is 0, that represents the x-axis. So y is 0 over here, everywhere y is 0. Okay, so we understand that. If I say x is equal to 1, that means if this is the point where it is 1, 0, a line passing through this line which is parallel to y-axis at a distance of 1 unit, this line would be nothing but x equal to 1. Okay, but our focus majorly on the linear equations with two variables, which is ax plus by plus c equal to 0. So as I told you, the first utility is identification of a straight line. What can be other utilities? Well, a is the coefficient of x while b is the coefficient of y. So let's say if I have something like this, 3x plus 4y is equal to 120. Now this is in general form. How? The constant term has been sent towards the right hand side. So here we can utilize this in such a way that if I'm able to find any value of x, let's say here I can clearly see that 120 is a multiple of 3. 40 times. So if I put x as 40, y will be 0. Utility is that x will change by the coefficient of y. So if I increase x with the coefficient of y, let's say, sorry, it's 4. If I increase, let's say I decrease x by the coefficient of y, that is minus 4, becomes 36. So the corresponding value of y will be 3 more. 3 comes from the coefficient of x than 0. So this is how it goes. So if someone tells you that x and y are integral, then what can be their values depending on different conditions? It can be negative integers, positive integers, or values within a range from 1 to 100, how many values are there? So this is what we can use. This is the utility of general form. The values of x and y. Corresponding values of x and y, in fact. All right, the next one. I'll keep this short. Slope-intercept form. So if a line is in this form, y is equal to mx plus c. Now you will think, line was in the form ax plus by plus c equal to 0. That was the general form. What does this form mean? By the way, here m means the slope and c means the y-intercept. Now y-intercept is the point at which the line cuts the y-axis. For example, I have something like this, okay? And it says here that y is equal to 2x plus 3. Now, it means that the slope of the line that I'm going to draw, the slope will be 2, and the point at which the line will intersect the y-axis will be 3. That is the y-intercept. I'll just show you how to draw that. Well, it'll go something like this. This point will be minus 3 by 2, comma 0, and this point will be 0, comma 3. So the utility of this is to find the slope of any line, and second is to find the y-intercept of any line. Now, what is slope? Slope is the rate of change in vertical distance with respect to the change in horizontal distance. So it means that if x moves by one step, all right, x, that is horizontal change, is one step, then the vertical change will be 2 steps. That is what it essentially means. All right. Now, having said that, here the slope, as you can see, is 2, which is a positive slope. So the slope is positive, the line would always be tilted like this. That means from the x-axis, if I want to draw an angle, this angle will always be less than 90, or an acute angle. And slope is nothing but tan theta. So in case you know tan theta, it's okay. In case you don't know, it doesn't matter. Theta here is less than 90. So any value of tan theta, where theta is less than 90, is always a value, this kind of value, a positive value. So that is how we understand that the slope is positive. Slope is positive, the line will look like this. All right. So here you can imagine this. If I move, let's say, from this point to this point, horizontal growth is this. Vertically, it is moving from this point to exactly this point. So growth is positive. X goes positive, Y goes positive. If I go downwards, so let's say X moves from here to this point. So as you can see, it is moving leftwards, that is negatively. X is moving negatively. Correspondingly, Y is moving from here to here. Y is also moving negatively. So negative upon negative is positive again. So that is the reason that if we have a positive slope, the line will look like this. In case we have a negative slope, the line will look like this, because here the angle theta is greater than 90 and less than 180. Tan theta, the value of tan theta when theta is more than 90 is negative. Cool. Now let's go to the next form, that's called two intercepts form. This is like x upon a plus y upon b is equal to 1. Here a is x-intercept and b is y-intercept. I told you what does intercept mean. So y-intercept in the previous case was the point at which the line was cutting the y-axis. X-intercept will be the line, the point at which the line will be cutting the x-axis. So let's say this is the xy axis, and let's say we have a line which looks like this. X by 2 plus y by 3 is equal to 1. If I want to draw this line, I'll just draw a line like this, where this point is 3 and this point is 2, the x-intercept and the y-intercept. All right. Now, all the forms are interchangeable. They are all interchangeable, which means, so the utility of this is to draw the straight line. So people normally, when they draw the straight line, they take the value of x as minus 2, minus 1, 0, 1, 2, then corresponding value of y, then plot the curve. So this, we can plot the curve without doing all of that effort. How? So let's say I have a line which looks like this. 2x plus 3y is equal to 6. All right. This is in general form. I can convert this into, see, this is general form. Let's convert this into slope-intercept form, which should look like this. How to convert anything into a slope-intercept form? You should have y in the left-hand side, x and constant term in the right-hand side, and the coefficient of y should be 1, which means 3y in the left-hand side, 2x goes in right hand side, becomes minus 2x plus 6 is there. And I want the coefficient of y to be 1. I can divide whole thing by 3. I'll get y is equal to minus 2 by 3 times x plus 2. So here I can see that minus 2 by 3 is the slope of the line, while 2 is the y-intercept. All right. Now, same thing can be, this is slope-intercept form. In 2-intercepts form, I can divide this whole thing by 6. So 2x by 6 plus 3y by 6 is equal to 6 by 6. What do I get? I get x by 3 plus y by 2 is equal to 1. Here you see how easy it is for me to draw the graph of this line, where I know that the point at which line will intersect the x-axis is 3 and at the y-axis it is 2. Look like this, 3, 0, 0, 2. This is going to help you a lot in coordinate geometry questions and even understanding how a graph of straight line behaves. So all these three forms are very, very, very much necessary. I repeat, general form to identify the line, point number 1. Second, to guess, or not just guess, calculate the values of x and y which satisfy the equation. That is general form for slope-intercept, to identify the slope and to identify the y-intercept. And 2-intercepts form, the main utility is to draw the straight line graph properly. So this is my favorite, because this helps me in drawing any graph. So I'll just give you one more example. Here I have the xy axis coordinate system. If someone tells you, hey, Abhishek, do one thing. I want to draw the graph for 3x plus 7y is equal to 210. What I'll do, would I start putting values of x as 0, 1, 2, 3, 4 and I don't know what? No, I'll just see, okay, what if I divide this whole thing by 210? Because x by a plus y by b equal to 1 was this 2-intercepts form. I need 1 here. How do I get 1 here? By dividing everything by this constant term, by 210. So 3x by 210 plus 7y by 210 is equal to 210 by 210. Now if I do that, what do I get? X by 70 plus y by 30 is equal to 1. Wow, it's in slope-intercept form. I'll draw the graph. This is 70, 0. This is 0, 30. How cool is that? I hope you understood this well. Coming to the next thing. Number of solutions. This is a very important question. Form 1. Ax plus by equal to c, where a and b are factors of c. Important note, a and b are co-prime to each other. So let's say we have like this, 2x plus 3y is equal to 60. I want to know how many natural solutions are there. Natural. Obviously, if I ask you integral, it will be infinite. A straight line has got infinite length, so it can have infinite points. But if it asks about only about the natural solutions, which means it's asking about, so if I try to draw, I'll show you. I divide this by 60, I'll get x by 30 plus y by 20 equal to 1, which means the graph will look something like this, where this point is 30, 0, while this point is 0, 20. Now I want you to calculate the natural solutions, number of natural solutions. So would you actually start calculating it? It seems impossible. So this is going to be a shortcut for you. How to do that? See, one way is to use the general form, which I told you. Here I can see 2 is also a factor of 60 as well as 3. If I put x as 0, y will be 20. But then I cannot consider this case because I need natural number of solutions. Next, I need natural solutions. That means I need x should be more than 0. So I'll try to grow x by how much? By coefficient of y. Becomes 0 plus 3 and y declines by coefficient of x. That is by 2. 20 minus 2 is 18. Let's keep on doing this. I'll get 6, then I'll get 2 less, 16, 2 less, 2 less, 2 less. So you can, kind of guess also. At 2, these things are natural and one point of time becomes 0. So when this is 0, this is 30. I'm not calculating all of it. So I can see here 2 9s are 18, 2 1s are 2. I have 9 natural solutions. All right. And if I add this and this, which I had rejected because they were not natural, there will be number of whole solutions. That means 11 whole solutions. So this is one way of doing it. So let's say we have a bigger number. It will be very tedious for us to calculate all of it. So here comes the shortcut. Okay. 60 divided by mod of 2 into mod of 3. What do you get? 60 upon 6 is 10. You need to subtract 1 for natural solutions. You need to add 1 for whole number of solutions. That's all. That is the shortcut. Interesting stuff, right? So if someone gives you something like this, 3x plus 4y is equal, let's say 120. How many natural solutions are there? Just divide 120 by 3 into 4. You got 10 here. Subtract 1 for natural, add 1 for whole. So we have 9 natural and 11 whole solutions. This will happen only if A and B both are factors of C. Okay, so to generalize it, AX plus BY plus C is equal to C. If both A and B are the factors of C and A and B are co-prime, the number of natural solutions will be C upon mod of A into mod of BY. I put mod because it can be minus BY as well. Doesn't really matter. But that will come, if it is minus BY, then we won't be having natural solutions. We'll be having X positive, Y negative. We'll come to that in the real classes, but this is the shortcut. So it's just subtract 1 to find the natural solutions and just add 1 to find the whole solutions. This is applicable when A and B both are positive. If they're not positive, we'll talk about that in the real classes. Okay, now comes form number 2. AX plus BY is C, where either A or B is a factor of C. So here, let's take an example. So 3x plus 4y is equal to 30. Here I can see 30 is a multiple of 3 but not of 4, which means I can put y as 0, so x will be 10. If I put x as 0, y will be 30 by 4. But it's not a natural number. Let's decrease x by coefficient of y. 10 minus 4 is 6, 6 minus 4 is 2. Here, y plus 0 plus 3. These two are the natural solutions. But you see here, if I decrease it further by 4, I get minus 2. Here, I'm not getting whole solutions at all, right? I'm not getting 0. Like x cannot be 0. Y can be 0. So here I've got 2 natural solutions, but 3 whole solutions. Now, how to solve this one? Take 30, divide by 3 into 4. 30 upon 12 is 2 point something. Take the greatest integer of it. This will be the natural solutions. Mod is there. Okay. 30 upon 12 is how much? 2 point something. The greatest integer of 2 point something is 2 only. The integral part. We need to take the integral part. 2. And just add 1 to it. In case you want to have the whole number of solutions, just add 1 to it. So the shortcut is C upon mod A mod B. Greatest integer, integral part of this is equal to number of natural solutions. And if I add 1 to it to get whole solutions. Interesting. Coming to the next one. I hope you guessed that. Neither A nor B is a factor of C. Do we have a shortcut for this? Not really. What we can do here is, so let's say I have 3x plus 4y is equal to 50. 50 is neither a multiple of 3 nor a multiple of 4. What to do here? So here the only thing that comes to our mind is the conventional way in which we'll have to calculate one value of either x or y and then go accordingly by the changing x and y by the coefficient of each other. To find the first value, that is the shortcut, which I'm going to discuss today. So here I can write y as minus 3x upon 4 minus 3x plus 50 whole upon 4. That's what I can write. That is possible. All right. Also, I can write x as 50 minus 4y whole upon 3. This is a better way, not this. So here what is going to happen, I need x to be an integer and y to be an integer. So I need to put a value of y in such a way, an integral value, that x also becomes integer. How to do that? So I will try to find the modulus. I'll see 50 divided by 3. So 3 16s are 48. I write it as 48 plus 2 and minus 4 as minus 3y minus y. You know what happened here? Now this 48, see, this 48 and this minus 3y become irrelevant. Why irrelevant? Because these two things would always be divisible by 3. Here I broke down 50 as 48 plus 2 because 48 is the multiple of 3, and minus 4y as minus 3y minus y because minus 3y is the multiple of 3. What's not a multiple of 3? That is 2 minus y. To have 2 minus y as a multiple of 3, what can be done? We know that 0 is a multiple of everything. So 2 minus y, if it is equal to 0, my life will be sorted. In what case 2 minus y will be 0? When y is 2. So at y as 2, I get my first solution. Let's put y as 2 here. 4 2s are 8. 50 minus 8 is 42. 3 14s are 42. I got the first value, rest I can find out. How? Decrease x by coefficient of y. 14 minus 4, minus 4, minus 4. Here, add 3, 5, 8, 11, and we got 4 such solutions. So here we'll be able to find natural solutions only. Whole solutions are impossible because a and b both are not the factors of c. Shortcut here is not this. Shortcut here is this, where we rewrite numerator as a multiple of the denominator. Hope you understood that. All right. Now, a very important, apparently difficult concept, numbers of solutions. Ax plus by equal to c, where c is unknown, a and b are co-prime. Type 1, find the minimum value of c if x and y are natural numbers. Interesting. So here, let's say someone asks you 3x plus 4y is equal to k. All right. And we want the minimum value of k if x and y both are natural numbers. Belong to, this symbol means belong to, n is natural number. What can be done? No problem at all. Natural numbers, okay. What is the least natural number? I want k as minimum. That means x and y should also be minimum. Let's start with minimum value of x. So minimum natural number is 1. I'll put 1 here. I need 4 solutions. Okay, cool. I asked the question as 4 solutions. 4 natural solutions. I'll put 1, then x will be growing. So I need natural. That means I need next value to be more than 1. So how much more than 1? 4 more than 1. By general form, 1 plus 4 is 5, 5 plus 4 is 9, 9 plus 4 is 13. I'll stop here. I need only 4 solutions. And for y, which will be declining because x is increasing, y will be declining by coefficient of x, that is 3. So I'll start from the, downwards. Let's put 1 here. Why 1? Because 1 is the minimum natural number. 1 plus 3, 4 plus 3, 7 plus 3, 10. We got 4 solutions. That's all. What's the value of k? You can solve any of it. 13 and 1. 3 into 13 plus 4 into 1 is the value of k, the minimum value of k. 39 plus 4, I got 43 as the answer. Interesting. Interesting stuff, I must say. What's the next form? Find the maximum value with their natural numbers. Okay, no problem in that. The maximum value. How to find the maximum value when both are natural numbers? Before that, let us try to do minimum value when k and y are whole numbers, because that will be easy for us. So we take the same example with 3x plus 4y equal to k. So let's say 3x plus 4y is equal to k, and someone asks that what is the minimum value of k if x and y belong to whole numbers. X and y, I'll just write that again. 3x plus 4y is equal to k. Find the minimum value of k if x and y, the elements belong to whole numbers. I think you guessed it right. What is the minimum whole number? It's 0. I'll start with 0. That's all. 0 plus 4 plus 4 plus 4. I got 4 whole solutions. Y should also be starting from 0. 0 plus 3 plus 3 plus 3. That's all. So let's put this value. 3 into 12 plus 4 into 0. 36 is the answer here. Interesting, isn't it? Now, the two types which are left, I hope you guessed it right. When both, what is the value when we have to find the maximum, k max? So for the same question, 3x plus 4y is equal to k, I need to find the maximum value of k where x and y both belong to the set of natural numbers, maximum. So x and y here. What can I do? How can I maximize this? What should be taken? Because in the previous case, we knew that I took x as 1, in whole case I took x as 0. So here what has to be done? To maximize the value of xc, if x and y are natural numbers, you have to solve for the minimum value of k when x and y are whole numbers. When you solve this, whatever value you get, just subtract 1 from it, and that's the answer. All right, minimum value of k when these are whole numbers, which is C, 36. Just take 36 minus 1, 35, that would be the answer. I'll repeat, if you want to find the maximum value of k in these kind of questions, where x and y are natural numbers, so to maximize the value of k, here it is C, to maximize the value of k when x and y are natural numbers, just that the answer will be 1 less than the minimum value of k when x and y are whole numbers. This is not the answer here. Whole numbers, and here you have to find, because I asked you k max when x and y are natural numbers, and we need 4 solutions. So here you need to find the minimum value of k when x and y are whole for 5 solutions, not 4. I'm sorry for that. 5 solutions. So for 5 solutions, the minimum value of k for whole numbers, just subtract 1 from it, and you'll get this. So I'll just solve it for you. 3x plus 4y is equal to k. I need k max when x and y belong to natural numbers. The process is, here is the process. Find k min for 5 solutions. Here we needed 4 solutions, all right? 5 solutions where x and y belong to the set of whole numbers. Okay, let's do that. So 3x plus 4y equal to k, 5 solutions, whole number, start with 0, 0 plus 4, plus 4, plus 4, plus 4. I got 5 values. Start with 0, that's all, 16, 0. You can go upwards or you can just leave that because you need the value of k. Even if you get one solution set, it'll be fine. 3 into 16 plus 4 into 0. You get 48. So 48 is the minimum value of k for 5 solutions of this equation where x and y are whole numbers to max. So just subtract 1 from it. Let's take 47. The moment you take 47, it will be the maximum value of c, in this case k, when x and y are natural numbers. So if you want to have n solutions, n number of natural solutions, just find the minimum value of k for n plus 1 number of whole numbers, whole solutions, and subtract 1 from it. That's all. Nothing else needs to be done. All right, we're done with that. So now there is a problem, the last problem, the maximum value of c if x and y are whole numbers. The maximum value. What can be done? Whole numbers. So I need 0, they're whole numbers. I need 0. Here I can't really do anything. You know what? The maximum value of c if x and y are natural numbers, that is going to be the solution for maximum value of c when x and y are whole numbers, because all natural numbers are whole numbers as well. So this type is irrelevant. It's same as finding for natural numbers. That's all. Hope you enjoyed. Put a feedback at iQuanta's CAT preparation FB group and go for the next video. Thank you. What you watched here is just the trailer, but picture abhi baki hai mere dost. If you want to access this whole module, it's a part of iQuanta's CAT all full courses. Don't wait. Check the link in description box and I'll see you in the classes.